Welcome to qnawire.
Hello everyone, this is the solution to problem 3 of college physics. So here, this is a follow-up question to the previous one where you were asked to find the intensity radiated by a light bulb onto some screen that is a given distance away. So in that problem, we found that the intensity at the screen would have been 0.80 watts per meters squared. So this is the initial intensity. Now we're told in this problem that we should assume that the light emitted by the light bulb is unpolarized. So if it then goes through a polarizer, as the question asks, then what happens is that because there are vibrations in all transverse directions, the direction of motion of the wave, which is represented here by this front view, if you like. So if you looked at the light ray then in some kind of a sketched version, this is what you would see. You would see vibrations along all directions. And so when you pass this through a polarizer, then it's only the vibrations along the axis of polarization of the polarizer that make it through. And so this essentially reduces your intensity by half. And the reason for that is because all of these components are then getting projected onto the axis of polarization. And so the only things that you don't get a contribution from are the ones that are actually perpendicular to the axis. So basically anything that's polarized along this axis here does not give you a contribution, but everything else does. And so it effectively reduces your intensity by half. So the answer to part A, which is asking you what is the polarization as it passes through, or sorry, what is the intensity as it passes through the first polarizer, is just going to be half times the incident polarization or the incident intensity. And so this just works out to be 0.40 watts per meter squared. And so this is the intensity that's going to make it through to the second polarizer, which is an axis of polarization that is rotated 50 degrees with respect to the first polarizer. And so what happens there is that as it passes through, you have to project. You can imagine that there's an electric field that is essentially going up and down along the axis of the first polarizer. And so you have to project this electric field onto the axis of polarization of the second polarizer. And so because the intensity is related to the electric field squared, you actually pick up a squared cosine function as you rotate through this angle. So the answer to your part B is going to be that S final is going to be S that was in the middle times cosine squared of the angle that is relative, or the angle between the first polarization axis and the second polarization axis. And so this is cosine squared of 50 degrees. And if you just put in the numbers, then you're going to get that this is 0.17 watts per meter squared. And so that is the answer to part B.